You're welcome to Excellent Simplified Tutorials.
Alright, so we'll be looking at precursors for de novo synthesis of purine nucleotide. Now, we want to synthesize, we already know what purine nucleotide is now, right? Good. Nucleotide containing purine bases. Now, what do we need? De novo means from the scratch. We want to synthesize it anew. That's de novo. We are synthesizing it from the scratch, from the beginning. We are not taking amphibolic substances. We are not taking substances from the cell. We want to synthesize our own from the scratch. So what do we need and where do we get those things we need to synthesize them from? Now, this is our purine base, right?
Yes, sir.
These are purine base. Now, this carbon, nitrogen, and all these things, where do we get them from? We already know how to number this. We've done that. Now, our nitrogen 1 is provided by what? Aspartate. Aspartate is an amino acid. So, aspartate provides nitrogen 1. Carbon 2, N10 formyl tetrahydrofolate. N10 formyl tetrahydrofolate provides carbon 2. Nitrogen 3 and nitrogen 9 are provided by what? The amide nitrogen of what? Glutamine. So it's gotten from glutamine. Carbon 8 is provided by what? N5, N10, Met9 tetrahydrofolate. Carbon 6 is provided by what? CO2. Now, this carbon 4, carbon 5, and nitrogen 7 is provided by glycine. So glycine provides carbon 4, carbon 5, and nitrogen 7. Now, this is summarized here. Glycine provides carbon 4, carbon 5, and nitrogen 7, right?
Yeah.
Aspartate provides nitrogen 1. Glutamine provides nitrogen 3, nitrogen 9. Tetrahydrofolate derivatives provide carbon 2 and carbon 8. Carbon 2 and carbon 8. While carbon dioxide provides carbon 6, right? Now, to remember the precursors of the purine base synthesis, you can use good guess, actually careful. Yes, good guess, actually careful. Good, glycine, right? Good guess. Guess, glutamine, right? Aspartate. Truly, tetrahydrofolate derivative. Careful, carbon dioxide. So this can give a clue of the derivatives. So if you forget everything we've said, don't forget that aspartate provides nitrogen
1.
Carbon 2 and carbon 8 is from what? Carbon 2 and carbon 8. Tetrahydrofolate derivative, right? Nitrogen 3, nitrogen 9. Glutamine, right? Carbon 6. Carbon dioxide, right? Now, carbon 4, 5, and nitrogen 7 is on what? Glycine. The more you use it, the more it sticks. And the good thing is, as we are going to synthesize, you are going to see how they come in. And you don't need to cram it. So have you listened on this? Now, let's look at the synthesis, the steps involved in the de novo synthesis of purine nucleotide. You already know that in the purine base, carbon 6 is provided by what? CO2, right? Good. Nitrogen 3 and nitrogen 9 is provided by what? Glutamine, right? Carbon 2 and carbon 8 is provided by what? Tetrahydrofolate derivatives, right? Carbon 4, carbon 5, and nitrogen 7 is and what? Glycine, right? What is remaining? Nitrogen 1 is what? Aspartate. And we use the acronym. Good guess are what? Actually careful. Right? Actually careful. Good. Now, let's look at how we synthesize that. The first thing is the activation of ribocyphosphate. That's not the first step, but that's the starting point. This is ribocyphosphate. You know, ribocyphosphate is already in the cell, can be gotten from the pentosuccate pathway, is it not? Now, this ribocyphosphate is activated with ATP. Now, we transfer a pyrophosphate. Pyrophosphate means what? Two phosphate attached, right? If I remove 2 phosphate from ATP, remember ATP is adenosine triphosphate, right? If I remove 2 phosphate, how many is left? 1, right? So that's why we are giving out AMP. So I took the 2 phosphate from ATP and I attached it here. Now, the only thing you are changing in this structure is only on carbon 1. It's only here. Everything here remains the same until we finish. So the only thing we are changing is just here. So here, the pyrophosphate is attached here. As you can see now, pyrophosphate. You can write this out in full as this. This is how to write it. You know, this one phosphate, another phosphate. If you are writing it one like this, is good. You put it in circle like this. Good. Now, this is phosphoribosylpyrophosphate, pyrophosphate, right? Remember, this is ribosyphosphate. So, making it a substituent now, we call it phosphoribosyl, then pyrophosphate we added. Good. That's the very first thing. Activation of ribosyphosphate to what? Phosphoribosyl pyrophosphate. Please, when I ask, say it out because you must get it in your head before you leave here. Phosphoribosyl pyrophosphate. Good. Now, the next thing is glutamine is coming in and leaving as what? Glutamate, right? Glutamine is coming in. Remember, glutamine was donating what? Nitrogen what and what? Nitrogen what? 3 and nitrogen. Good. So we are producing 1 nitrogen now. So as glutamine comes in and provides its amide nitrogen, the nitrogen comes here and gives out the pyrophosphate. Do we get? Gives out the pyrophosphate. So what we are now having now is phosphoribosylamine. From phosphoribosyl pyrophosphate, we've gotten phosphoribosylamine. Don't forget, the first thing we activated ribosyphosphate to what? Phosphoribosyl pyrophosphate. Glutamine comes in and leaves as glutamate, and we have what? Phosphoribosylamine. Good. Now we've gotten phosphoribosylamine. Remember, in a purine ring, the sugar is connected to the base at what? Nitrogen what? 9, right? It means this is our nitrogen 9 we formed already, because nitrogen 9 and nitrogen 3 was on glutamate, right? From glutamine, is it not? This is our nitrogen 9. As we go on, you see. So this is also ribosylamine. The next thing is glycine comes in. Remember, glycine provides what? Carbon 4, 5, and nitrogen 7, right? Good. Now, glycine, the whole of glycine comes in. If you agree with me, the structure of glycine is like this. This glycine, right? We are attaching the whole of glycine here with the carboxyl end. So now, look at this. This OH here will take 1 hydrogen and go out, right? This OH takes 1 hydrogen. This is, you know, this is the same thing as doing it this way. Is it not? Now this OH takes 1 hydrogen from here, goes out, right? So what we are having left is what? CO, right? This CO connected to this CH2, connected to this NH2, is it not? So the name is no longer phosphoribosylamine, but glycinamide ribosyphosphate, because we've attached glycine, so it becomes glycinamide ribosyphosphate. We started with ribosyphosphate, we activated it to what? Phosphoribosyl pyrophosphate. From phosphoribosyl pyrophosphate, glutamine comes in and we got phosphoribosylamine. Glycine comes in now to form what? Glycinamide ribosyphosphate. Good. Now, glycinamide ribosyphosphate. Now, this is our nitrogen 9, right?
Yes.
Carbon 4, carbon 5, nitrogen 7, is it not?
Yes.
Good. Now, the next thing is N5, N10 tetrahydrofolate comes in. And remember, tetrahydrofolate derivative was providing carbon 2 and carbon what? 8, right? Now, this N10, N5, N10 tetrahydrofolate comes in and provide our carbon 8. Now, tetrahydrofolate is always a carrier of 1 carbon unit. This is the 1 carbon unit, an aldehyde. And anytime tetrahydrofolate is coming in, there is a name that will be attached, a prefix that will be attached for me. Anytime tetrahydrofolate is coming in, we attach for me. That is why as tetrahydrofolate came in to attach this one carbon unit, the name changed to formylglycinamide ribosyl-5-phosphate. So anytime glycinamide is, tetrahydrofolate is coming in, we attach that name formy. Now formylglycinamide ribosyl-5-phosphate. The next step, if you notice, nitrogen 9, carbon 4, 5, nitrogen 7, carbon 8. We've completed this ring, right? But we will not close it yet. So let's see what to do to the other ring before we close it. Now the next step is glutamine. Glutamine was providing nitrogen what and what? 3 and what? 9. And 9, right? We already produced 9. So glutamine comes in again and leaves as glutamate and provide this nitrogen, which will serve as a nitrogen what? Nitrogen 3, right? So from formylglycinamide ribosyl-5-phosphate, we now have what? Formylglycinamidine. This is an imine. So we will now form formylglycinamidine ribosyl-5-phosphate. Don't forget, we started from ribosyl-phosphate. We activated it to what? Phosphoribosyl-pyrophosphate. From phosphoribosyl-pyrophosphate, glutamine came in to form what? Phosphoribosylamine. From phosphoribosylamine, what else did we get? Glycine came in and we got what? Glycinamide ribosyl-5-phosphate. From glycinamide ribosyl-5-phosphate, N5, N10 tetrahydrofolate came in and we got what? Formylglycinamide ribosyl-5-phosphate. Now glutamine comes in again to donate nitrogen 3 and we got what? Formylglycinamidine ribosyl-5-phosphate. Good. I'll give you an acronym to remember all these names, but understand how it's moving. Now, formylglycinamidine ribosyl-5-phosphate. The next thing is ring closure. This ring here will close. This ring here will close. And that ring closure, now, look at how it happens. Remember, this is same thing as like this. Right? Yeah. This double bond will fall back here. I don't want to go into the mechanism. This double bond will fall back here. This one comes here. The ring will close. Just know what is happening here is a ring closure. The ring closes. And as the ring closes, we form our what? Aminoimidazole. As the ring closes, we now have aminoimidazole. This is an imidazole ring, right? Imine is attached. So we have aminoimidazole ribosyl-5-phosphate. So from formylglycinamidine ribosyl-5-phosphate, we have aminoimidazole ribosyl-5-phosphate. For this is not recording. We'll start from the starting. All right, so aminoimidazole ribosyl-5-phosphate. The next step is carboxylation. This is nitrogen 3, right? Yes. This is nitrogen 3. So the next thing, carboxylation. Remember, what was bringing CO2 was providing what? Carbon what? 6, right? So carbon 6. So carboxylation, we attach this where our carbon 6 is always. So carboxylation, CO2 comes in and donates carbon 6, which will form what? Aminoimidazole carboxylate ribosyl-5-phosphate. What we were having before is aminoimidazole ribosyl-5-phosphate. Now that we carboxylated it, we have aminoimidazole carboxylate ribosyl-5-phosphate. The next step after that, aspartate comes in. Remember, aspartate was donating what? Nitrogen 1. Aspartate comes in. The whole of aspartate will come in and attach. If you agree with me, the structure of aspartate, aspartic acid, right? This aspartic acid, right? Now the whole of this we attach here. The whole of this will attach here. Now how is it attaching? Look at this. Look at this. It's attaching to one of the carboxyl group, right? Is it? No, it's attaching here at the amino group. One OH here. Now you know this is written as this is same thing as this. Is it not? Yes. So this OH here will take one hydrogen. Is it not? And what we have attached is NH, right? NH linked to what? CH, right? The CH here is linked to this and this, right? So the CH is linked to this and this. So the whole of aspartate attached, And if we attach aspartate to amino imidazole carboxylate ribosylate 5-phosphate, what we now have, we call it succinine. Amino imidazole succinine carboxamide, not carboxylate again. Amino imidazole succinine carboxamide ribosylate 5-phosphate. Now, after forming that, the next thing is we don't need the whole of this. It's only nitrogen 1 we want. So all these ones will be cut off. An enzyme called adenylosuccinase will come in and break off these parts. Break it off. This one will leave as fumarate. Break it off. And we are left with just that amino group we wanted, right? And the name becomes what? Amino imidazole carboxamide ribosylate 5-phosphate. So we remove the succinine. So we just remove this. So this is the only thing leaving that name. As this one leaves the name. So we are having amino imidazole carboxamide ribosylate 5-phosphate. Now the next thing is, for me comes in again, right? To produce carbon what? Carbon 2, right? So carbon 2 N10 for me tetrahydrofolate comes in to donate 1 carbon unit again. This 1 carbon unit. And we form for me amino imidazole carboxamide ribosylate 5-phosphate. For me amino imidazole carboxamide ribosylate 5-phosphate. I just added for me to this name here because 1 carbon unit is coming in.
Now this ribosylate 5-phosphate is
ribosylate 5-phosphate. Now because of space, I'm just writing the name out, ribosylate 5-phosphate, but you can still draw this stuff we've been drawing since, all these ones. But because of space, I just wrote ribosylate 5-phosphate. Ribosylate 5-phosphate. Now, for me amino imidazole carboxamide ribosylate 5-phosphate, cyclization takes place. Water is going out, so water is removed from here. H, this OH, right? This double bond oxygen here. Now cyclization takes place and we form our first purine ring, amino inosine what? Monophosphate. Inosine monophosphate. Now before I give you the acronym, let's see what really happens. We started with what? Ribosylate phosphate, right? Ribosylate phosphate was first activated by ATP to form what? Phosphoribosylate pyrophosphate. Now, phosphoribosylate pyrophosphate, glutamine comes in, right? And as glutamine comes in, we form what? Phosphoribosylamine. Phosphoribosylamine. Now, glycine comes in and we form what? Glycinamide ribosylate 5-phosphate, right? Is it not? Now, the next thing, N5, N10, N10, N5 comes in, right? Tetrahydrofolate derivative comes in to form what? For me, glycinamide ribosylate 5-phosphate, right? Another glutamine comes in again to form what? For me, glycinamide ribosylate 5-phosphate. Then the ring closes, right? To form what? Amino imidazole ribosylate 5-phosphate. After the ring closes, the next thing that will come in is what? Is what? Carbon dioxide, right? So carbon dioxide comes in to donate carbon 6 to form what? Amino imidazole carboxylate. Carboxylate, because we are attaching our carboxyl group now. Amino imidazole carboxylate ribosylate 5-phosphate. After then, what is coming in now?
No, aspartate.
Aspartate comes in. Aspartate, the whole of aspartate attached, right? To form what? Amino imidazole succinine carboxamide ribosylate 5-phosphate. After that, the whole of this part we don't need will be removed, right? Will be removed and will form what? Amino imidazole carboxamide ribosylate 5-phosphate. So we've removed this succinine. Now the next thing is what? For me group will come in, right? 1 carbon unit to form what? For me amino imidazole carboxamide ribosylate 5-phosphate. The ring closes to form what? Inosine monophosphate. Good. Yes. So to use this acronym, just think of right people. The right people do two things. The right people, they will physically and gladly form formal amino accounts. And after doing that, they will assign accounts formally and innocently. Think of somebody working in the bank and think of yourself. Now, if you are a right person, you will physically go to the bank to open an amino account. The person serving you, if it's a right person, will not be biased, will not say, I know this one, so let me open account for this one first. The person will assign account, open the account formally and innocently. Good. So, right people physically and gladly form formal amino accounts, assign accounts formally and innocently. Right here is what? Ribophosphate will first be activated to what? Phosphoribosylpyrophosphate, right? Phosphoribosylpyrophosphate to be converted to what? Phosphoribosylamine. Phosphoribosylamine, glycine comes in, will be converted to what? Glycinamide ribosyl 5-phosphate, right? Now, from glycinamide ribosyl 5-phosphate, for me, glycinamide, for me what? For me, glycinamide ribosyl 5-phosphate, right? Then the next thing, glutamine comes in to form what? For me, glycinamide ribosyl 5-phosphate. From me, glycinamide ribosyl 5-phosphate to what? Amino imidazole ribosyl 5-phosphate, right? From amino imidazole ribosyl 5-phosphate to what? Amino imidazole carboxylate. So as you can see, AC, amino imidazole carboxylate ribosyl 5-phosphate, right? Now from amino imidazole carboxylate ribosyl 5-phosphate to what? Amino imidazole succinylcarboxamide ribosyl 5-phosphate, right? So the two letters are giving you the difference. This is amino imidazole carboxamide ribosyl 5-phosphate. This is amino imidazole succinylcarboxamide ribosyl 5-phosphate. Then after amino imidazole succinylcarboxamide, it will leave, the succinyl will leave, right, to form what? Amino imidazole carboxamide ribosyl 5-phosphate, right? After that, to form what? For me, what? For me, amino imidazole carboxamide ribosyl 5-phosphate. Ring closes to form what? Inosine monophosphate. So if you forget everything we've said today, don't forget that right people will do what? Physically and gladly form formal amino accounts, assign account formally and innocently. This one will be easy for you to cram. If you've crammed this, at least this will give you hints of what is going on. Is it not? Alright, so that's that.